Okay, I hope that you can all hear me right now. Okay, so good morning also by my side. My name is Besikiotis Athanasios. You can call me Thanasis if it's easier for you. So my background is mechanical engineering, focusing on structural dynamics. And I'm a former Alter employee, such as Paschalis. And we are both based in Thessaloniki in Greece. So thank you very much for having us here today. And let's see, for the first presentation here, let's see an overview of our Simcenter simulation portfolio. And afterwards, for the second presentation, we are going to see the engineering AI part in more detail. So as you can see in this slide here, Siemens has invested over 20 billion euros. The goal of Siemens since 2007. So the goal of Siemens is to bring closer the digital world with the software and closer the digital world with the real world, meaning the automation. So this has been done through the Simcenter simulation portfolio, which basically enables us to transform engineering. With Simcenter simulation portfolio, we are the most comprehensive as we can be, meaning we can access lots of different scenarios of multi-physics simulations and analysis. And of course, the portfolio applied to all phases of our product development. We are as intelligent as we can be, meaning we are integrating AI into simulation world. And of course, as Paschalis mentioned about the AI agents and AI workflows. So we're streamlining and automating our complex workflows with the help of AI. And we are scaling and evolving our resources. And through Simcenter simulation portfolio, we are able to integrate simulation and tests into the digital thread. So here you can take a taste of where Alter's portfolio fits into the Simcenter portfolio after the integration, the acquisition, of course. And basically, these are the key areas that we're going to talk about today, about the kind of different multi-physics and different domain simulations. So let's start with the simulation modeling and visualization software family. When we're talking about simulation and visualization, we mean, I'm sure that you all already know, we mean about pre-processing our models, importing our CAD, pre-processing, setting up, creating the mesh, setting up our solvers, and afterwards, when the solver has run, to visualize our results. So let's see the flagship of Alter, Simcenter Hypermesh. Let me ask a quick question. How many of you know Hypermesh? Can you please raise your hand? Okay. And how many of you have used Hypermesh? Okay. That's nice. Thank you. So Simcenter Hypermesh has been the flagship of Alter and now Siemens for more than 30 years. So basically, it's the go-to tool when it comes to pre-processing our structural analysis. It has great capabilities when it comes to importing our CAD. There are PDM connected workflows that enable us to get the metadata information and transform them and utilize them into our workflows, engineering workflows. Of course, there are consistent tools across geometry modification and simplification and creating our meshes. Of course, Hypermesh in HyperMesh, we can import different kinds of CAD formats. And within HyperMesh, we are able to set up our analysis for different solvers, meaning Abacus, Nastran, and so on. So, of course, Simcenter HyperMesh is interoperable. And HyperMesh has great capabilities when it comes to programming. So it is open and can work through Python APIs that help us automate our workflows. Now moving on with Simcenter Hyperview. Simcenter Hyperview is a great software when it comes to visualizing and animating our results. So inside Hyperview, we can import different kinds of solver formats and, of course, CAE domains and disciplines. So we can visualize our results from a CFD case, from a structural case, and so on. Again, it can work through Python APIs, meaning we can accelerate our workflows. And of course, it has advanced capabilities when it comes to visualizing our results. We can synchronize our data with animations, with plots, and of course, we can create advanced reports through Simcenter Hyperview. Now, let's move on to Simcenter Hypergraph, which basically, again, it's a post-processing, a visualization software. But in this case, it helps us create plots and advanced plots and graphs. So Simcenter Hypergraph has advanced capabilities when it comes to visualizing our plots and has advanced mathematical functions, meaning we can transform our graphs with these advanced mathematical functions. Of course, we can compare and analyze data from multiple sources. And again, as HyperMesh and Hyperview, it can work through Python APIs, meaning it can make our life easier and boost our engineering workflows. Now about Simcenter SimLab, which is the tool when it comes to setting up, pre-processing our multi-physics analysis. So through SimLab, we can run simulations, we can set up simulations when it comes to structural, dynamics, thermal, solder fatigue, and also electromagnetics now. And it has advanced capabilities when it comes to AI-powered optimization. And of course, we can set up electrical and mechanical co-simulation scenarios. And once again, it has great capabilities when it comes to bidirectional CAD coupling for geometry modifications. And also through SimLab, we can run DOEs, we can run optimizations, and in this way, we are able to find our optimal designs. Now with Simcenter HyperMesh NVH, which basically is the software responsible for the noise, vibration, and harshness analysis. So through it, we are able to, through quick what-if studies, to find our sensitive parameters. And also, we are able to bring closer to correlate our simulations with our tests, meaning we are able to minimize our experimental tests and also our prototypes. And it is an end-to-end solution, meaning it has also integrated visualization tools. And of course, can be used for many different subsystems of vehicles. So meaning we can use Simcenter HyperMesh NVH for the trim body, for the powertrain, for the suspension systems, and so on. Also about Simcenter Inspire, which is the simulation-driven design for manufacturing software, meaning we can run design explorations based on our physics. By doing so, these design explorations, we are setting, for the design explorations, we are setting our constraints to be manufacturing constraints. So in this way, we are able to find our optimal manufacturable designs, but also taking into account our physics. And with Simcenter Inspire, we have the ability for advanced hybrid modeling, meaning inside it we can manipulate different kinds of geometries all together in one model. For example, we can have into our model polynerbs, also along with facets, along with boundary representations, and so on. So let's move on to the mechanical and manufacturing simulation software family. So we're going to divide this domain into 3 different domains. So the structures, meaning the structural side, when solving the structural analysis. The second one, the mechanisms, when it has to do with the multi-body dynamics simulations. And last but not least, for the manufacturing part, manufacturing processes. So let's start with the structural simulations, meaning our detailed CAE analysis. So here, the first tool that software that we're going to see is Simcenter OptiStruct. Simcenter OptiStruct is a multi-physics solver that utilizes the one model and one solver methodology. So basically, in Simcenter OptiStruct, we can run explicit simulations, implicit simulations, non-linear, linear, and so on. Also, it has great capabilities when it comes to linking the implicit, explicit continuation. Also, it has great capabilities when it comes to optimizing our components. So within OptiStruct, we can run topology optimization, topography optimization, free shape optimization, and many more different optimization methods. And it is open architecture, meaning it can be linked with other third-party solvers when it comes to co-simulation scenarios. Now, another tool, very different from what we've seen so far, is Simcenter SimSolid. SimSolid is a meshless solution, meaning there's no need for geometry simplification and for meshing. We are able, with SimSolid, to run structural, thermal dynamics, and also fatigue analysis. So it is a multidisciplinary structural tool. And with SimSolid, we are able to have our results up to 100 times faster than traditional CAE tools. And it's a simulation for all software, meaning even non-CAE experts, for example, designers, can also utilize SimSolid in order to get really, really fast the results that they want after a design modification, for example. Now, Simcenter Radios. So you can see in the video some use cases that we can run with the solver of radios. So Simcenter Radios is an industry-proven solver responsible for explicit dynamic scenarios. So with Simcenter Radios, we can run impact simulations, crash analysis, blast, and other type of explicit dynamic simulations. It has unique solver compatibility with third-party solvers, meaning we can run directly external solver decks into radios. For example, we can run directly LS-DYNA solver text. And with the help of Simcenter radios, of course, we can run many simulations. We can create, with these results, a dataset that we can afterwards train our AI models for fast physics predictions. Now, Simcenter Hyperlife, which is the tool, the software that enables us to simulate fatigue and crack growth for durability purposes. So within Hyperlife, we can set up complex fatigue models, and it is an open architecture software, meaning we can simulate the fatigue and the life from using data from different CA software. Also with Simcenter Hyperlife, we can simulate the life and the fatigue of spot welds and also sim welds. And it enables us to ensure our product's life and warranty with its high fidelity results. Now moving on to the multi-body simulation side. So when we're talking about multi-body simulations, as you've already know, we're talking about large mechanical assemblies with high velocities, for example, or rotational velocities, large rotational velocities, and so on. So let's start with Simcenter Motion Solve. Simcenter Motion Solve acts as a solver for our multi-body simulations, and it enables us to, as the motto says, to breathe life into our mechanical systems, into our assemblies. So it helps us to simulate and get deeper insight into our complex mechanical assemblies before doing the prototypes and all the testing. Also, with Motion Solve, we are able to extract load time histories for each component separately in order to have them for a detailed CA analysis afterwards. And once again, it is as hypermesh, hyperview, hypergraph. It can be utilized through Python APIs, and it is an open architecture software, meaning it can link and run alongside with different third-party solvers in co-simulation scenarios or via subroutines. So now Simcenter Motion View. So Simcenter Motion View acts as the preprocessor for our multi-body dynamic systems. So through Motion View, we are able to simulate our mechanical systems, and we are able to build and store our mechanical system and events into our libraries with variants. And in this way, we are able to reduce the repetitive work. Also, it comes with the vehicles tools extension, meaning that inside this database, inside this library, there are lots of kinds of different scenarios, simulation scenarios for durability and for dynamic simulations for ground vehicles. And once again, with this vehicles tools extension, we are able to simulate the different subsystems of our vehicles. So, for example, we can simulate the suspension system, the steering wheel system, and so on. And it also supports many popular tire models, pre-calibrated tire models. Sorry. So once again, another preprocessor for our multi-body dynamics simulations is Simcenter Inspire Motion, but this time Simcenter Inspire Motion is, as the motto says, for one user but two personas. So with its easiness of use and with its freedom that provides the user and flexibility in the modeling process, it is not necessary that only analysts can set up multi-body simulations, but also designers. So it has automatic CAD CAD geometry feature detection. We can rapidly create flex bodies within our simulation. Of course, we can run DOEs and optimization studies in order to optimize our mechanical systems. And since it acts as a preprocessor, we are using MotionSolve once again to run and get our results. Now, just an overview for the manufacturing solutions that we offer under the umbrella of Inspire. So basically, when we're talking about manufacturing processes, as you already know, we're talking about simulating the manufacturing, but why? In order to find defects or faults beforehand, before creating the prototypes, and in this way to optimize and to improve our products, but also by simulating the manufacturing processes, we are able to, for example, calculate the residual stresses within our components. And in having the residual stresses, we are able to have them as material properties into our detailed CAE simulations in order to get more accurate results in the end. So you can see the different tools, different software responsible for the manufacturing processes according to the manufacturing, of course, process that we're going to execute in the real world. Now continuing with the fluid simulation. So when it comes to the fluid simulation, we offer different kinds of software, of solutions. So let's start with HyperMesh CFD, Simcenter HyperMesh CFD, which is a unified CFD simulation for aerodynamics and aeroacoustics. It is a single interface for geometry, meshing, post-processing, and reporting. It is 80% faster compared to other software. Also, with HyperMesh, we get high-fidelity results that lie closely to our tests. And, of course, we can run DOE studies in order to explore our design spaces and help us improve our designs, our products. And also, it has seamless integration with AI solutions, meaning through HyperMesh CFD, we can create dataset for future AI model training in order to deploy AI models, physics AI models for faster results. Now, Simcenter FlightStream. So, Simcenter FlightStream is an advanced panel method, also combined with computational techniques for fast and reliable results. So it gives us, FlightStream gives us results across the subsonic and also hypersonic domains, bandwidth, let's say. And there's no volumetric meshing, so no need to create volume mesh. It's faster, much faster compared to traditional CFD simulations. And it works seamlessly with NX, SolidWorks, ANSA, and Pointwise. Now moving on to the Simcenter UltraFluid, which is a high-fidelity CFD solver for aeroacoustics, but also in this case for transient aerodynamics. So ultrafluid enables us to eliminate greenhouse cabin noise issues for the grounded vehicles. And with its high fidelity results, it boosts the aerodynamic performance, meaning we can optimize and improve our products. Now with Simcenter nanofluid, you can see here a very nice example of how nanofluid can help us simulate the oil supply system inside the gearbox. So it's a smooth particle hydrodynamics solver. It helps us, it is basically mesh-free, so it's easy also for non-experts to set up their simulations. And it helps us basically to simulate the flows, high-speed flows, also liquid-air interaction, and also high-speed flows when it comes to very complicated surfaces and very complicated domains. And for the CFD part, here the last solution is Simcenter IDEM, which basically utilizes the discrete element method. So through IDEM, we are able to simulate bulk and granular material. It has pre-calibrated materials for example, for soil, for coal, for tablets, and so on. It is also multi-GPU enabled in order to get our results faster. We can simulate scenarios when having millions of particles. And of course, its strength, let's say, is when it comes to co-simulating with IDEM alongside with, for example, multi-body dynamics tools, for example, with Motion Solve, and also other CFD software. Now, let's see the solutions that we've got inside the Simcenter portfolio, simulation portfolio, when it comes to creating materials and handling materials. The first tool is Simcenter Material Modeler, which basically enables us to translate and transform raw data, raw experimental material data, into simulation ready to run material cards. So it has advanced capabilities and automated workflows that help us create these material cards for multiple CAE domains, disciplines, and also for different, for multiple solver formats, meaning we can export these material cards to, for example, OptiStruct or to Radios and so on. And it is integrated with Simcenter Material Data Center, which we're going to check afterwards, for secure data sharing across our company, across the different teams of our company. So Simcenter Material Data Center, it's basically a database for materials, for thousands of materials. These materials are validated across the industry and include polymers, metals, and also composites. And of course, there is seamless integration with CAE workflows, meaning when I'm setting up my simulation within Hypermesh, I can simply click when I want to import the material, click, basically a window pops up and guides me to the Simcenter material data center, and through it I'm able to import the specific material card for my simulation setup. There's full traceability, and of course we can manage, store, and share data into secure and private databases. Now moving on to the electromagnetic simulation, so meaning the high frequency electromagnetics and the low frequency electromagnetics. We've got three solutions here that we're going to see. So Simcenter FECO is the leading software, the leader, when it comes to high frequency electromagnetic simulation. Through FECO, we can design and test antenna positioning, for example, as you can see in the video, or we can simulate the radome modeling, meaning the radar and the dome. We can check for interference, electromagnetic interference, and analyze radar and electromagnetic effects. It is an end-to-end solution, meaning we can handle, there are improved workflows that we can handle from geometry modeling up to result visualization and reporting. And also supports integrated tools like WinWrap, WRAP, and WinProp. Now, moving on to the low frequency electromagnetics and Simcenter Flux. So Simcenter Flux helps us to optimize our electromechanical equipment in order to improve our products, our final products. So we can simulate magnetostatic or steady state or transient conditions along with thermal and electrical properties. Also, there is seamless multiphysics optimization with multiphysics constraints in order to optimize, once again, our products, and also provides us with high fidelity electromagnetics results in order to be closer to our tests for correlation purposes, and also rely more on the simulation part rather than creating our prototypes and running lots of multiple experimental tests. Simcenter Flux Motor, here is the tool, the software, when it comes to topology optimize our electrical motors. So it is dedicated to the design of our electric motors. Once again, with the workflows that provides us, it is a go-to tool when it comes to improving the performance of our products. So we can run optimizations, we can explore our design space of our electrical motors while considering multiphysics constraints. Of course, we can generate customizable reports in order to get the insights from our results, and it helps us to, once again, to improve our products. Now, we are moving on to the final part of this presentation for the engineering applications and engineering AI. Also, on the second presentation, we're going to get into more detail about the engineering AI part, but let's have an overview here of the products. So when we're talking about engineering AI, in this case, we can split this section into two different sections. On the multidisciplinary design analysis and optimization tools, software family, and also to the engineering data science software. So for the multidisciplinary design analysis and optimization, let's see Simcenter Hyperstudy, which is a multidisciplinary design, space exploration, and optimization software. With Simcenter Hyperstudy, we are able very effectively to create data through DOEs and optimization studies to help our multidisciplinary teams to study our complex systems. And we can very easily create the data, run our optimization or DOEs, and very effectively post-process our results, meaning, for example, creating a Pareto front or post-process the results in any way that we want, we desire. It is integrated, it can work basically with different kinds of solvers. It can call different solvers in order to run DOEs and the optimizations. And also through Hyperstudy, we can deploy our predictive AI models. And we can share the models very effectively and very easily between our teams. Now for the engineering data science part, so meaning utilizing deep learning methods to extract insights from past simulations and also test data. So we can feed this data to create predictive models that afterwards can help us to accelerate our design exploration studies and get faster results with these predictive models. Of course, and also in this way, we can reduce our computational sources when running these design exploration studies. So the first tool here, the first software that we're going to see is Simcenter Physics AI. So Physics AI is a geometric deep learning engine that isn't limited to parametric studies, meaning we can utilize past historical simulations that aren't parameterized, that the geometry or the boundary conditions or the forces aren't parameterized. We can also, of course, use test data. We can train Physics AI on this data. And after the training has finished and is successful, and we are satisfied with the results, we can deploy this predictive model in order to replace the traditional FE simulations. And in this way, we can reduce the time needed in order to get our results. And in this way, we are able to evaluate more design variations in less time. Now, Physics AI Studio. So Physics AI Studio broadens the value that Physics AI brings. Physics AI Studio basically is an enterprise cloud-based solution that enables all the teams across the company to create the data very effectively, to train the AI models, and to share them across all the company in order to deploy them, let's say, in a web-based platform for fast physics predictions. Now, last but not least, the software here that we're going to talk about is Simcenter ROM AI. So ROM AI is a reduced order modeling technique which uses either simulation data or test data, but these data are organized into a CSV file and need to be parameterized, of course. And with ROM AI, basically is a deep learning method that also combines dynamic system theory for dynamic systems. And we train it, as you can see here. And we are able to deploy these ROM AI models in order to get faster predictions. And of course, it can find use in many different applications. So for example, we can replace a traditional solver, or we can export, for example, this ROM AI model into functional mockup units, into FMUs, in order to get them installed on hardware, or it can be used as a virtual sensor in the real world. So it can find many different applications. And basically, that's it by my side for now. I'm open to any questions that you have in your mind. And once again, thank you very much for having me here today. Thank you. Yeah. Yeah, of course. You can ask me anything also on the breaks, or if you have something in your mind now, you can feel free to ask, basically. Okay, I guess there's no question.